f of a is equal to 2a e power minus a square.
2a e to the power of
Power
minus
minus
a
a
square.
square.
This is also, we said this is also the Rayleigh fading. Yeah, this is also the Rayleigh distribution, right? Rayleigh fading distribution. And what is the distribution of the gain? G is equal to a square. What is the distribution?
E power minus g.
That is e power minus g, and this is the exponential distribution, correct?
Yes, sir.
Thank you, thank you. Let me try to see if I can interact with any other college. Just let me see here. BTKIT. Is there anyone from BTKIT college? BTKIT. Is there anyone from BTKIT? No one from BTKIT. VCAP college. Do you remember what we said about the AWGN channel last time? Remember we
Yes, sir.
discussed about the AWGN channel. Does anyone remember about the AWGN channel?
Yes, sir.
What did we say about what is the system model for the AWGN channel? That is, we said y is equal to
Plus n.
x plus n, where n is the additive
Noise. White Gaussian noise.
additive white Gaussian noise. So the AWGN stands for, everyone can hear me? Can you hear me?
Yes, sir.
It stands for additive white Gaussian noise, where the noise is Gaussian, meaning that if I look at the distribution of the noise, look at the distribution of the noise is Gaussian with zero mean, that is mean, and variance sigma square. Right, so if I draw the distribution of the noise, how is it going to look like? It is going to look like a Gaussian curve. Where is the center of this Gaussian curve? Can someone tell me where is the mean is 0, where is the center? Sorry, I cannot hear you. Maybe the microphone is switched off. VCAP college, can someone tell me how is the distribution of the Gaussian noise?
Yes, sir. It's about the
How is the
origin.
distribution of the Gaussian noise?
It's a bell-shaped curve at origin.
Bell-shaped curve at 0, right? Centered at 0.
Centered at 0.
What is the meaning of white noise? We also talked about this concept of white noise, right? What is the meaning of white noise?
An impulse noise, whereas
So if I look at the autocorrelation, that is Nk into Nl, that is equal to basically sigma square of delta K minus L, which is basically, it is an impulse at the, that is, if I look at the autocorrelation, it is an impulse at 0, and therefore if I look at the power spectral density of this noise, that is, therefore if I look at the power spectral density, the noise power spectral density, the noise power spectral density,
constant with amplitude
that
frequency.
is basically, how does it look like? It looks like the Fourier transform of the impulse, that is constant sigma square. Therefore it has the same, it is basically flat over all frequencies similar to the spectrum of white light. Therefore this is known as white noise. Okay, thank you so much. I got the answers. Let me just try to see if I can interact with someone else. Hello RVIT college, are you able to follow it? Are you able to hear and see me? LNMIT, are you able to hear me? LNMIT.
Yes, sir.
Are you able to follow what I'm saying about the white noise, Gaussian white noise? Are you able to follow what I'm saying about the Gaussian noise?
Yes, sir.
Okay, fine. Does anyone remember what we said about the BPSK modulation last time? If I'm looking at BPSK modulation of of power P, what are the transmitted symbols? So now I'm talking about BPSK modulation. Can someone prompt me on the chat if someone remembers what is the BPSK modulation? Can someone prompt me on the chat if someone remembers what is the BPSK modulation? So I want to look at BPSK modulation of power plus or minus power P. What are the transmitted symbols? Does anyone remember what are the transmitted symbols corresponding to BPSK modulation of power P? Anyone remembers? Any college, can someone prompt me on the messenger if someone remembers what is the BPSK modulation symbols corresponding to power P? Okay, I think GEC college and VCAP both are responding. That is, the symbols are plus or minus square root of P. That is, if I have BPSK modulation of power P, the symbols are, that is, symbols transmitted are plus square root of P and minus square root of P. So for, let's say, for transmitting the symbol, so we have a string of information symbols, 0, 1, 0, 0, 1, 1, 0, 1, so on. So I have to modulate this string of symbols. So let's say I am transmitting for every 0, I am transmitting square root of P. For every 1, I am transmitting minus square root of. For every 1, I am transmitting minus square root of. I am transmitting minus square root of P. MIT Karnataka, you have a question? Does everyone remember what we did in the last lecture?
Yes, sir.
So for BPSK modulation, what are the transmitted symbols? You remember, right? What are the transmitted symbols for BPSK modulation?
Plus 0 for plus P and 1 minus 2P.
Okay, so fine. So we have transmission of square root of p and minus square root of p. This is BPSK modulation. We also said BPSK stands for binary.
Shift keying.
BPSK stands for binary phase shift keying. Right, binary phase shift keying, which is a digital modulation scheme. The reason it is known as binary phase shift keying is because the phase is binary. That is, either it is plus square root of p or minus square root of p. So the phase is either 0 or pi. Therefore, it is known as binary phase shift keying. Also, because the transmitted symbols are plus square root of p and minus square root of p, the average transmitted power is P. That is, the power is half times P, corresponding to basically probability of half for symbol plus 1 and power P, and also half times, because both plus 1 and minus 1 are being transmitted at power P. The average power of this scheme is basically does anyone have any questions here? So this is a BPSK modulation. So basically what I'm considering here is the following thing. I'm considering an AWGN channel. My channel is basically it is y equals x plus n, and we are saying the following thing. We are saying x is BPSK symbol. X is either plus square root of p or minus square root of p. Right, so x, these are BPSK symbols, either plus square root of p and minus square root of p, and the noise is basically Gaussian noise. This is white Gaussian noise, of variance sigma square. So the noise is a Gaussian noise of variance sigma square. Right, this is the communication system model that we are considering. So basically, if we now let us look a little bit more deeper at this thing. So let's say we consider, so let us go back to our system model. Y equals x plus n, right, and noise has a Gaussian distribution with 0 mean. Let us say I transmit plus square root of p. What is the distribution of the y, received y? If I'm looking at the transmission of plus square root of p, what is the distribution of the received signal
That root.
y? Can someone answer this and tell me what is the distribution of the received signal? Anyone can answer. If you know the answer, can you prompt me on chat? What is the distribution of the received signal y corresponding to the transmission of plus square root of p? What is the distribution of the received corresponding to the transmission of plus square root of p? So I'm getting the answer. It is a Gaussian that is centered at square root of p. I think VGAP has replied that is the Gaussian. That is because the noise is 0 mean. Basically, to noise n, if I add, so what I'm receiving is if x is plus square root of p, I'm receiving n plus square root of p. Therefore, what I will get is I will get a Gaussian that is centered at plus square root of p. Similarly, when I look at minus square root of p, when I transmit minus square root of p, I will receive a Gaussian which is centered at minus square root of p. Therefore, now you can look at it by symmetry. Y can either be, it can be from minus infinity to infinity. However, if y is greater than 0, then there is a greater probability corresponding to square root of p. For instance, let us say I receive this particular value of y. Then the probability corresponding to the transmission of plus square root of p is greater than the probability corresponding to transmission of minus square root of p. If let's say y is less than 0, y is this value, then the probability corresponding to, this is the probability corresponding to minus square root of p, and this is the probability corresponding to square root of p. Looks like someone has a question. Let me try to see if someone has a question. VPCOE. VPCOE, do you have a question?
Yes, sir.
Go ahead please.
Sir, we have written one equation y is equal to x plus n, where
Correct.
where y is the transmitted signal, x
X is the transmitted
transmitted signal, and y is the received signal, and we are writing instead of x plus square root of p or minus square root of p,
Right.
and the power of signal is p.
Right.
And yes, so I am asking the question whether plus square root of p and minus square root of p is the amplitude of that signal or any other property.
It is the amplitude, correct. So x is equal to plus square root of p or minus square root of p. It is the amplitude of that signal, correct. That is the signal. It is the signal
So
level basically.
Yes,
it is not
yes.
simply the amplitude, it is the amplitude and the phase also, right? It is basically the signal level.
Signal level. But in the last lecture, I heard about the relation between power and amplitude. That is, if amplitude is A, power will be the A square.
Correct.
Yes. So here if
So
I
that is
take
why
the
amplitude is minus square root of p.
Yes, sir. But if you are taking only amplitude of the signal to represent the signal, then will be the signal, the whole signal, or we are only taking the amplitude of that signal. We are not concentrating on the phase of that signal and other purpose.
That is what I am saying. The phase is also there, right? This is binary phase shift keying. The signal can be square root of p or minus square root of p. So there is both amplitude and phase, right? Because if it is square root of p, the phase is 0. If it is minus square root of p, then the phase is pi. This is the entire signal. It is neither the amplitude nor the phase. It is both amplitude and phase. This is the signal level, right?
Okay.
Does that answer your question?
Yes, sir.
Okay. Okay. Thank you. Okay. So what we are saying is, thank you. So what we are saying is the following thing, that if I transmit, if I receive y is greater than 0, then the probability corresponding to of square root of p is more. And if y is less than 0, then the probability corresponding to the transmission of minus square root of p is more. Therefore, my detection rule can be the following. Detection rule at the receiver. Let me write this down. Detection rule. Can everyone hear me? This is the detection rule. If y greater than 0, then plus square root of p. Hello? 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 Yeah, so if y is greater than 0, then it is plus square root of e. On the other hand, if received signal y is less than 0, then we are going to detect it as minus square root of p. Therefore, when will there be error? If you can clearly look at that, I will have error. If you can see, I will have error if I transmit minus square root of p, but the received y is greater than 0, that is corresponding to this probability And also if I transmit plus square root of p and I receive y is less than 0, corresponding to this probability, I will have error. So error will occur. Yeah, I think there is a problem. Someone is complaining that the mobile is close to this. I will switch off my mobile. Let me just switch off my mobile. Yeah, sorry, I'm just switching off my mobiles. Okay, thank you. Is that better now? BTKID, is that okay? Everyone, is that okay? Yeah. So what I'm saying is, if the square root of p, if I received y, if I transmit minus root of p and received y is greater than 0, right? And if I transmit, or if I transmit square root of p and the received y is less than 0, then there is going to be error. So error is going to be there. Error is going to be there. So error will occur if plus square root of p is plus square root of p is transmitted and y is less than 0. What this means is, if I transmit square root of p and the noise is very negative, so negative that the y is actually less than 0, that is a high negative value of the noise, a large negative value of the noise, that will result in error. Or if minus square root of p is transmitted, minus square root of p is transmitted and y is greater than 0. So, and if minus square root of p is transmitted but the noise is such a large positive value that it is greater than 0, then there will be error. So the conditions of error are basically if plus square root of p is transmitted and the received signal y is less than 0, or if minus square root of p is transmitted and the received y is greater than 0. These are the conditions for error. Okay, right? Now let us go to evaluate the probability of error. Let us consider a simple scenario. Let us go back to our scenario where we are transmitting, we are transmitting minus square root of p we are transmitting minus square root of p and we are receiving y greater than 0. This is the probability, right? Now let us start with some basics. If minus square root of p is transmitted, so we have y is equal to minus square root of p plus n. What is the distribution of n? Can someone remember what is the distribution of n? That is Gaussian noise, mean 0, variance sigma square. What is the distribution of n? What is the function? What is the distribution function or the probability density function for n? Can someone remind me what is the probability density function for n? Can someone prompt me on chat what is the probability density function of n? What is the probability density function for n? Does anyone remember what is the function for Gaussian distribution? MIT, do you remember what is the function for probability distribution of the probability density function of the Gaussian?
One by root 2 pi sigma square e raised to minus n square by 2 sigma square.
Thank you. Yeah, that is 1 by square root of 2 pi sigma square e raised to minus n square divided by 2 sigma square. Now I have n minus square root of p. So what is the distribution of y? What is the distribution of y?
By root 2 pi sigma square raised to minus of n minus 2 the whole square by 2.
What is the distribution of y? Can you repeat that question? Can you repeat that please? The distribution of y. First, what is the can you describe it in just without giving me the mathematical expression? How will you get the distribution of y? Can you describe it?
N has to be shifted to minus 2.
What is that? Can you hear me louder, please? I cannot hear you.
General distribution is 1 by root 2 pi sigma square e raised to minus of x minus mu the whole square by 2 sigma square. Here mu
Okay,
is equal
correct.
to minus 2. Mu is
Okay, so
equal to
basically
minus
what
2.
you are saying is, thank you. So what you are saying is basically this is a Gaussian which the mean has been shifted by minus square root of p, correct? So mean has been shifted by minus square root of p. Is that correct?
Yes.
Is that correct?
Sir.
Fine?
Yes, sir.
Okay. So basically now what we are saying is the following thing. So the distribution of y is now we are also saying the error will occur if y is greater than 0. Error will occur if y is greater than 0. Error if y is greater than 0 implies now y is equal to minus, because minus square root of p is being transmitted, error will occur if y is greater than 0. Now y is greater than 0, y is equal to minus square root of p plus n, which is greater than 0, implies n is greater than square root of p. So error if n is so error will occur if n is greater than square root of p. Is everyone following this? So what we are saying is, again we are saying the similar, we are saying something similar, that is I will have an error, that is I will have an error if y is greater than 0. Y is greater than 0 implies that n is greater than square root of n is greater than square root of SGG college, SGG SIET. Are you able to follow me? Are you able to hear and follow me? Okay, so n is greater than square root of p. Now therefore, what is the probability of error? Now can someone answer this question? What is the probability? Can someone respond on chat? Probability, what is the probability the probability of error is the probability that n is greater than square root of p. How can I find this probability? What is the probability, or what is the probability that n noise is greater than square root of p? What is the probability that the noise is greater than square root of p? Can someone prompt me the answer to this? What is the probability that noise is greater than square root of
ಈ ಸಬ್ಜೆಕ್ಟ್ ಅವರು
ಹ್ಞೂ ಆರ್ ಬಿ ಸಿ ನೋಡಿ ಬಂದ್ಬಿಟ್ರು ನೀವೇ ಹೇಳ್ಬೇಕು ನಾವು ಗೊತ್ತಿಲ್ಲ
ಮೈಕ್ ಕೊಟ್ಟಿದ್ದೀರಾ
ಮೇಡಮ್
GHR college, can someone tell me what is the, how can I find the probability that the noise is greater than square root of p? Anyone, not only this college, anyone, can you respond to me on messenger, saying on the messenger, basically explaining to me how we can find the probability that the noise is greater than, the noise n is greater than square root of. Remember, noise is, what is the distribution of the noise? The noise is Gaussian distributed. If we go to the noise, what is the distribution of noise? Noise is basically, remember, go back here, we said noise is, everyone can see this, noise is Gaussian distributed with, mean 0 and variance sigma square. Therefore, the distribution of the noise, that also we have written down. The distribution of the noise, what is the distribution of the noise? The distribution of the noise is 1 by 2 pi square root of 2 pi sigma square e power minus n square by sigma square. Now what I am asking is, I am asking a simple question. How can I compute the probability that the noise is greater than square root of p? Can anyone tell me how can compute the probability that noise is greater than square root of p? Anyone has the answer? VIT Jaipur, can you hear me? VIT College Jaipur. Okay, so MIT College, I am getting an answer. The probability is 1 minus p, where n is less than square root of p. How will I compute the probability that n is greater than square root of p or n is less than square root of p? Can someone tell me the answer to that question? UIT, can you hear me? Inda?
Yes, I can hear you.
Can someone tell me the answer? How will I compute the probability that n is greater than square root of p? Any answer? PSG College of Technology, using error function. Yeah, using error function, but I'm not using for form. I'm looking for formulas. Can you explain me how I can? PSG College, are you able to hear me? Yeah, how can I find the probability?
Sir, integrate the PDF of n from root p to infinity.
Integrate PDF and
Root p to infinity.
okay, square root of p to infinity. Correct. Probability is nothing but the distribution of the noise integrated from square root of p to infinity. So this is f of n dn, because I know the distribution. If we want to find the distribution, noise is greater than p, then we have square root of p less than the noise less than infinity. Therefore, I have to integrate it between square root of, let me just rewrite this again. Therefore, I have to integrate this between square root of p to infinity, that is 1 over 2 pi sigma square e to the power of minus n square by 2 sigma square dn times dn. This is the probability of error. The probability of error is nothing but the probability that the noise is greater than square root of p. To find the probability that the noise is greater than square root of p, I have to basically integrate between square root of p and infinity. I have to integrate the density of the noise between square root of p and I have to integrate the density of the noise between square root of p and infinity. Now I am going to do some basic manipulations here for this integral. First I am going to make the substitution n over sigma is equal to x. Therefore we have dn is equal to sigma times dx. Now if I substitute this here in this expression, I will have P is equal to integral square root of P, because I am substituting n by sigma equals x, so this would be square root of P divided by sigma to infinity 1 over 2 pi under root sigma square e to the power of minus n by sigma is x, so this is e to the power of minus x square by 2 times dn is equal to sigma dx, so this will be sigma dx, which means this integral is basically equal to square root of p divided by sigma to infinity. Now there is a sigma over here and another sigma over here, so this will cancel, and then what you will have is 1 over square root of 2 pi e to the power of minus x square by 2 dx. Okay, so that is the value of the error function. There seems to be a question. Let me. Yeah. I'm getting MIT Karnataka. I'm getting a question whether it should be 2 times the distribution. No, it should not be twice this thing, because we are only considering the scenario where noise is greater than square root of p, right? Because we are transmitting minus square root of p, the noise is basically greater than square root of square root of p. That is where the error will occur. So condition on the transmission of square root of minus square root of p, the probability of error. This is the probability of error. Right? Okay, I hope that has answered the question. So let me just write it clearly on the next page. That is basically I have probability of error PE equals integral square root of p divided by sigma to infinity 1 over 2 pi e to the power of minus x square by 2 dx. Now observe that this function is basically, this is the Gaussian random variable. This is 1 over square root of 2 pi e to the power of minus x square by 2. This is a Gaussian random variable. The mean is 0 and variance equals 1. So this is basically a Gaussian random variable with mean 0 and variance 1. And what we are asking is, we are asking what is the probability that this standard Gaussian random variable is greater than square root of p over sigma. So this is the probability that x greater than or equal to square root of p divided by sigma, where x is the standard Gaussian random variable of mean 0 and variance 1. This function, that is the probability of x greater than or equal to a particular value, this is known as the Q function or the Gaussian error function. This is denoted by Q of square root of P divided by sigma. Therefore, the probability of error P is equal to the probability that x is greater than or equal to square root of P by sigma, which is equal to basically Q of square root of P by. So therefore, the probability of error is Q of square root of P by sigma. So what we have proved so far is the following. Basically what we have said is that the error probability corresponds to the noise greater than or equal to square root of P. The noise of variance sigma greater than or equal to square root of P is basically two function of square root of P divided by sigma. So basically the noise is equal to, so the probability of error is equal to Q of square root of P divided by sigma, and this can also be written as Q of square root of P divided by sigma square. And now you can see P divided by sigma square is nothing but also it is the SNR, that is P divided by sigma square equals the SNR of the system. So I can write this also as Q of square root of SNR. So the probability of error in this system is basically given as Q function of square root of SNR. So the probability of error is the Q function of square root of SNR. This is Q function is nothing but this is the probability. What is the Q function? We have already described the Q function. The Q function is basically nothing but the probability that the standard Gaussian variable of unit variance mean 0 is greater than or equal to. So let me define what is the Q function again. What is the Q function? Q function is, this is the standard communication error function. Q function is basically Q function is the probability that a Gaussian random variable of mean 0, and that is Q function is basically Q of x is the probability that Q function is the probability. UIT, can you able to hear me? UIT, are you able to hear me? Is the probability that a Gaussian random variable of mean 0 and variance sigma square is greater than x. That is, if I'm looking at, if I want to draw this thing, let me just clearly draw this and show this thing as follows. That is, if I have a Gaussian random variable and if I look at any point x, then what is the probability that this Gaussian random variable of mean 0 and variance 1 is greater than or equal to x? That is basically the Q function. This is the probability that the standard Gaussian random variable x of mean 0 variance 1 is greater than or equal to x, and therefore we said the probability of error equals Q square root of P divided by a sigma square equals Q square root of SNR. Now let us look at another interesting formulation. Of course, Q function, there is no closed form expression to calculate the value of Q function, so we can use an approximation for the Q function. U of x is approximately equal to half e to the power of minus half x square. Therefore, using this approximation, I can write Q of square root of SNR approximately equal to half e to the power of minus half SNR. So one can also write probability of error approximately equal to half e to the power of minus half this is also known as this is the another approximate expression. You can see that the error decreases exponentially with respect to SNR. Error decreases exponentially. So we have two different expressions. One is we have probability of error equals Q square root of SNR, which is approximately equal to half e raised to minus half SNR. Now, now let me ask you this basic question. Let us do a simple example. Let us say I want a probability of error P equals 10 to the power of minus 6. That is, I want a probability of bit error or bit error rate 10 to the power of minus 6. What is the SNR required? Can someone answer this question? We will conclude with this. Can someone quickly answer this question? What is the SNR? P equals half e to the power of minus half SNR. What is the, so let us use this expression, P is equal to half e to the power of minus half SNR. If my desired probability of error is 10 to the power of minus 6, what is the SNR that is required for this communication? Can someone prompt the answer to me? If my desired probability of error is 10 to the power of minus 6, what is the SNR required? Can someone quickly answer this question? Anyone? Can anyone prompt me on chat? What is the answer to this question? Okay, I'm getting the numerical answer, but what is the exact? So given what is the expression for that? That is, of course, everyone can see now that PE, so this is 10 to the power of minus 6 is equal to half e to the power of minus half SNR. Therefore, correct, I think what I'm getting is basically SNR equals log 2 into 10 to the power of minus 6 log of that times minus 2. And what is the answer corresponding to that? Minus 2 log to the base e, of course, that is log natural, minus log 2 into 10 power minus 6. And what is the answer? I am getting from MU Jaipur, that is 26.24. Can someone else also calculate and confirm to me? What is the answer? Can someone else, can someone clarify what is the answer? Can someone confirm what is the answer? Some college, can you confirm what is the answer? Okay, so 26.24. So that answer is 26.24. Of course, we have to express it in dB. What is the answer in dB? What is the 26.24? That is the answer. What is the answer in dB? That is, to get the dB value, I have to perform 10 log 10. That is equal to 14.19. Okay, thank you. So that is equal to 14.19 dB. SMIT, it is more, it is 14 dB, it's not 28 dB, it is 14 dB. There is some error in the calculation. It's 10 log 10 26.24. It is approximately 14 dB. There is a question. Answer is 24. I don't know if it is dB or linear. The linear value is 26.24. The dB value is 14 dB. There seem to be some other questions. Can I quickly take GEC College Tamil Nadu? GEC College Tamil Nadu, is there a question? There was some prompting. Is there a question? Okay, no question. MIT, is there a question? SMIT, is there a question? Is there any question from your side, SMIT? So if several people have responded, there is no question. Okay, they're responding on chat. Okay, so the answer is approximately for bit error 10 power minus 6. Approximately 14.19 dB is required. Alright, so we have basically completed the probability of error for an AWGN channel. What we are going to do next is basically we are going to derive the probability of error for a wireless communication system. Alright, thank you very much. If you have any questions, you can ask me in the next lecture. Thank you.